Anyway, come. Okay, so what I was saying just now is that complex number is the mother of all numbers. So again, what does it imply is that whatever you have learned before, since kindergarten, what do you learn in kindergarten? Apple plus apple, 2 apple, right? Orange plus orange equals to orange. Yeah. That's how you learn your addition, multiplication, subtraction, division. That's how you learn. So your basic 4 operations will work under complex number. Then when you move on to secondary school, you learn how to solve equations. You learn whatever, you learn your APGP previously, whatever sheet you have. So everything and every single thing they have learned so far will work under complex number scenario. So again, what does it imply? There's no boundary as to how they can test you for this topic. Okay, so this is how scary this topic is going to be. Can? Okay? Can? So let's move on now with your proper definition. So just now I asked you, is 3 a complex number? Yes, it is. So how do you actually represent a complex number is that I'm going to represent complex number. Typically the symbol to represent a complex number is Z. Okay? And Z is usually followed by a real part and an imaginary part. Okay. So if I tell you 3, how to represent 3? It is actually 3 plus 0i. But this one is redundant, so half the time we don't write this. Okay. So I can also write 3 plus 2i. This is a complex number. 3 minus 2i. Fractional or 27 over 3. Another 1 over 8 plus 2i. This is a complex number. So whatever number you put inside here, all these things must be real number. So it doesn't make sense if I tell you, oh, it's 27 over 3i plus 2i. It is rubbish now. Okay? Because I and I can simplify, right? Then this thing becomes real. Make sense? Okay? So technically, to be overarching, the general form of a complex number will be a real section plus an imaginary section. Important criteria, x and y must be real already. Can? Follow so far? Okay? Can? So easy thing. This is how you actually start off your complex numbers. And half the time, please remember this terminology. We call this the real parts. That means x is always the real parts, and then the y is the imaginary part. Okay? Easy? Okay, and remember this one. For F-math, we learn how we actually simplify this long chain of words that we write R-E-Z. Imply to the real part of Z. I-M, imaginary part of Z. Can? So far so good? Easy? Okay, come. Practice. Fill in the blank. This one, easy. Most of the time, it doesn't affect anything to the students. Comfortable? Comfortable? So just now, as I was saying to you, I displayed on I displayed on a Venn diagram for you. The real number is a subset of a complex number. Okay, if you cannot remember this, never mind. Just remember, a complex number is the mother of all numbers. Everything outside. Can? Okay, so just now, as I was saying, in kindergarten, you learn how to do your addition, subtraction, multiplication, division. So let's recap everything now. You know how to addition, right? How to do addition, right? So actually, there's nothing much to recap. So the only trick now is, if I got this, I want you to add to 4 plus 7i. How to add?
Real plus real.
Yeah, real add to real, imaginary add to imaginary. This plus this, you get 7. You get 9. Makes sense. If you want to do a subtraction, can you do a subtraction? Can do. Real subtract real, imaginary part minus imaginary part. That's it. Simple rule. Okay? Nothing really fantastic. All you remember is real add to real. Imaginary add imaginary. So it's just like your like terms add together. You group all the terms in terms of imaginary and real. Easy, huh? How about multiplication? How about multiplication? So what if I give you 2 plus I multiplied by minus 3 plus I? So multiplication is a little bit more complex. Complex in the sense that you must remember your secondary school distributive law.
Rainbow.
So yeah, some students call rainbow. Can you try activating your rainbow? What will happen? 2 times minus 3, you get minus 6. 2 times I, you get 2i. This one, you get minus 3i plus I squared. Make sense? After you do this, what must you do? Regroup. Real with the real. Imaginary with the imaginary. What's I squared? Minus 1. So you get a minus 7. This plus this, you get a minus I. So that is your result. So multiplication, remember distributive law or your rainbow. Easy? Division? How? How to do division? A bit different. So like that, 2 plus I. 2 plus 2, 3i. How to divide? Cannot rainbow.
Non-division.
Partial fraction? Don't create hell for yourself.
Non-division.
Long division? No. How to do long division? Not so easy. Secondary school, you have this special technique called realize the denominator. Can you remember? Or some school call it rationalize. So what do I mean by rationalize?
Isn't it non-division?
2 minus 3i over 2
2 minus 3i.
Oh, yeah.
Okay? I want you to focus on the denominator. Not numerator, ignore first. Focus on the denominator. A plus b, a minus b, right?
13.
So technically you get a 2 squared minus 3i squared. Make sense? But this thing becomes,
Oh.
so it's actually 2 squared plus 9. 4 plus 9. Make sense? So what you have at the denominator is actually a real number already, right? So what you have is 2 plus I, 2 minus 3i over
13.
Alright? And then the upstairs, the numerator, activate your rainbow, everything will come out. Can? So simple rule, how to do addition, how to do subtraction. How to do multiplication is just rainbow. How to do division, rationalize the denominator, everything will be fine. Can accept. So what you see in your lecture notes, okay, one whole list of x, y, all the formulas in terms of x, y, all these things. If you can remember, go and remember. If you cannot, don't bother. You just remember the rules is there. Can? So example 5, I think you just read through. Nothing much to do, right? Jump straight to the blank. Can you try filling in the blank on your own? Can you try filling in the blank on your own? Okay, because if you can understand, okay, just understand now. Don't need to bother about the notes. Okay, remember notes are down there for completeness. You don't have to read every single thing if you're okay with it. Any issues? We will get 13, right? Huh? Yes. But if you want to switch imaginary part in front, I cannot stop you. You should be marked as correct. Can, so we can just fast forward to the next part already. Okay, just check your answer for your 6 part 1 and 6 part 2. You should be able to handle all this on your own. Try. Don't just copy. Copying makes no sense. Just try. 6 part 1, activate your rainbow or your distributive law. Then regroup. Real part with the real part. Imaginary part with the imaginary section. Do not take you too long. Then in your 6 part 2, remember your rationalize or realize the denominator, and then the numerator, activate your distributive law, activate your rainbow. You should be fine again. Yeah. Yes. Don't worry, all these things are just practice. No. Hey, wait. There's a 4i 41 or 41. Yeah. All these are practice. Questions will be like that. Okay, so how you want to leave the form of the answer, whether you want to split into this part plus an imaginary part, or if you want to combine everything, you write like that, minus 3 plus 14. 14i over 41. Nothing wrong. No marks will be deducted. But anyway, these are just practice. Questions won't be like this. And make sure that you have the skills with you. That's all. And any issues? Simple. So far so good. Okay, so I've covered with you the do by hand, manual working behind this. So what I need you to do is get familiar with your calculator. Nothing really fantastic. All I need to do is to introduce to you where is the position of I. That's all. And you can just see it as it is. Okay, I is just above your decimal place. Okay, I is above decimal points. So in order to activate I, you just have to press second decimal point, your I will appear. By default, after you reset your calculator, it doesn't matter. Your calculator can function in complex number mode even after reset. So you actually don't have to do any settings to your calculator. Automatically it can function. Okay, just do some practice. What is 1 plus 2i divided by 5 minus 4i on your calculator. Okay, just key as it is. I is located above the decimal point. Okay, please make sure you remember your basic rules, brackets, all these things. Can or cannot?
Can.
Comfortable? Comfortable? Comfortable using a calculator? So knowing how to use a calculator is one thing. What's the limitation of a calculator?
Not exact.
Correct. Okay. So if your answer happens to be non-exact, the calculator cannot process everything for you nicely. So as of now, you'll be telling me, well, so how can it be non-exact? So a question that can possibly be set subsequently will be like this.
Where do I?
How? Press calculator. Can your calculator give you an answer? Square root of 3i got answer?
What's blue?
Well, heck, one string of sheet, right? Okay, so the answer happened to be non-exact. So how we want to, or rather how your examiner will test you is, give me the exact solution to square root 3i. So that's when I'm going to force you to do by hand. So understand the limitations of calculator, and then you'll more or less understand how examiners can set questions. So far so good? Yeah, so easy part. Let's move on. So as far as practicing on a calculator, I think this part is still quite intuitive. It's quite easy. Not much to understand. Not much for you to worry about as of now. So moving on, you settle your 4 operations already. Let's go one level up. So if I tell you that z is equals to 3 plus 4i, and I tell you w is equals to 7 plus 8i, otherwise is equals to a plus bi, where a and b are real, then I tell you z is equal to w. Can you tell me what's a?
3.
Can you tell me what's b?
4.
How do you do this?
Comparing coefficient.
You compare coefficient, right? Or technically in complex number mode, you say you compare the real with the real. Compare the imaginary part with the imaginary. Make sense? So you settle your 4 operations. Next one, when it comes to equation solving, your equation rules stay as it is, even under complex number mode. Can. Okay? So let's move on to the next example. If you can understand this, what does example 7 say? If x plus y plus I of x minus y is equals 5 plus 2i, can you possibly give me what is x and y? Okay? So you activate the same basis of comparison, right? Technically is compare real with the real. Compare imaginary part with the imaginary. So where's the real? X plus y. So x plus y must be 5. X minus y must be 2. So technically you actually generate simultaneous equation. From there you solve for your x and y. Make sense? Always remember, x and y are already real numbers. Okay, x and y are real number. Easy? So far easy, right? Because all these are the basic parts. Can? So far so good? So far so good. Now, as I said, this easy part. By the time you hit chapter 3, chapter 4, I tell you hate complex numbers already. I also hate it, don't worry. Okay, just now I tell you, complex number work for everything. But, it doesn't work for inequalities yet. Okay, because later on, inequalities can work. But right now, it cannot work. So I cannot say 7 plus I versus 7 plus 2I. So you cannot say, oh, real part the same, then I, oh, this one got more I than this, so this one is greater. No such thing as of now. Can? Inequalities can be applied in complex number under a different scenario. So you cannot say that I could do a basic comparison this way. It doesn't work. Can? Yeah, remember this. So, I settle for you for operations, I settle for you equation. So what happens if I escalate the problem now? It is a power 2 equation. Okay? Don't think complex number, think secondary school. If I give you a power 2 equation, how to solve? Like just now I give you this thing. X squared plus x plus 1. I ask you to solve for this. Give me all the available methods that you know as of now.
Complete square.
Complete the square. What? Factorize. What else? Quadratic formula. What else? Graph. What else? Graph is GC lah.
But wait, what's that called? Discover my voice.
Quadratic formula. What else? Anyone have any other fantastic method that can work? Okay. Can. So same thing. All you need to do is remember. Same rule apply. Whatever that can work in secondary school will work under complex number scenario. The only problem is if I ask you to factorize, it's going to get a little bit tricky. This one of course cannot be factorized. Okay? But if I ask you to factorize this thing, it's going to be a little bit tricky, right? Because you need to try to factorize it into one factor multiplied by another factor. It's not so easy because of the stupid I coming out. Okay, so factorization, it will still work. If you tell me you are very, very powerful, go ahead and use factorization. Or else, this one, chances are, cannot work for most students. Okay, so that will leave you with, which one do you think is the most effective?
Complete the square.
Can complete the square? Yeah. Technically, your formula is the most powerful tool when it comes to solving power 2 equation. But you must always remember, I'm telling you, all methods will work. The only thing is who is more efficient. That's all. Okay. So complex number, you must select the efficient method to do it. Don't go and try and factorize. Can you go and try? Think, it will work. But then after you get the solution, you go and refactorize. You get the same thing. Okay, we'll run through the test. Never mind. We'll let this. I'll let you try this later on. Okay. So in complex number, I tell you all these things will work already. But I want to introduce you to a method. Okay, which is called number 5, which is what we call the let z equals to x plus iy, where x is real, y is real. Okay, this method will be activated if, not just in chapter 1, chapter 1, chapter 2, chapter 3, chapter 4. If somehow that day you screw up, you don't know what to do already, activate this thing. Okay, this one, half the time, not say half the time, all the time it will work. The only problem is efficient or not efficient. So when I ask students to use this, sometimes the solution can go to 3 pages, 4 pages. But then if I ask students to do this, 2 line finish. Okay, but it all depends on your form that day, and depends on the question that makes sense. Okay, so I'm going to introduce this same question. We try solving the method 5, which is let z be x plus iy. So try You need to copy? Or everything put in for you already? Everything put in for you already, right? Yeah. So after everything that we put in for you, technically you run through the x plus iy expansion, handle the square. What do you do next is to equate, right? Or regroup. Regroup all the real things together, imaginary parts together. What to do after that? After you regroup, this is the real section. This is the imaginary, this is the real parts. Where's the imaginary parts?
Down there.
Yeah lah. Okay, this is the imaginary parts. So that is on the left. Okay, these are all the real parts. X square minus y square plus 3y minus 2y. These are the imaginary parts. Sorry, real part. This is the imaginary part. So if everything is supposed to be equal to 0, what it means is that the real part must be 0. The imaginary part must be 0. And again, from there, I generate two equations for you to solve for your x and y. Comfortable? Comfortable?
Oh, okay.
Then, this is the thing that I want you to please asterisk or pay special attention to. Okay? Because when you actually substitute this y value back into this equation, you actually realize that you're going to have x squared equals minus 1/4. Then many students tell me, hey, I learned complex number already. Why can't I solve this? I can solve this. But don't forget, what is your criteria on x and y? When we let z to be x plus iy, the condition that has preset for you is that these two must be real numbers. So if it happens that you got this one, x squared equals 1/4, negative 1/4 coming out, you still must tell me no solution. Don't tell me I learned complex number area I can solve. But because I preset the criteria, it must be real. Okay? So far so good?
And there will be no solution
No solution to what?
for
Original equation. So, wait So you are telling me, can there be no solution to this equation? Is it?
yeah.
No, impossible. Impossible. Why I say impossible? Even back in your secondary school, your teachers will teach you how to solve equations like this, right? Don't talk about this. Teacher will teach you how to solve this. Agree? And then what does your teacher teach you?
Compute square.
No, your teacher will teach you check discriminant, right? Then your discriminant will tell you whether you have two real roots, two distinct and distinct and real roots, or you have two equal roots, or no real roots. What's the basic fundamental behind this? Power 2 equation generate two roots. So it's a matter of them being real or equal, real or non-real. So similarly, extending the concept to this, even though my coefficient of my z is imaginary, but by virtue this is a power 2 equation, there will still be two roots. It's just a matter of what are the two roots, real or complex. Make sense? So I don't care what is the coefficient. This one will have two roots. This one also two roots, even though I have an I in front. How you decide number of roots is based on the power of your x. You understand? So if I extend since you asked this, like that, how many roots are there? 3. So as the thing, even if I put I or I down here, I will still have 3 roots, etc., etc., etc. Can? So far so good? Okay, this part, just fill in the blanks. Okay, so subsequently you get your two roots to be I or 2I. Okay, I or 2I for the two roots to your equation. So far so good. Any problem? Can? Okay, now let me ask you now. Since you just now asked me, z equals I and I or 2I, right? Can you express it in, what's the equation again? If I write it in factor form, it looks like that, right? Agree? If I can do this, that means actually I can factorize. Make sense? Will you be able to think of this if I give you the original rainbow? Of course, this one expand back, you can. But all I'm asking you now is, if we revert back to the original question. Okay, if we revert back to the original question here, could you have handled this question via factorization? Will you be able to see this thing?
Okay.
Some can, as I say, some can. Some will tell me, siao or what? It's crazy. Make sense? You will need a bit of skill to be able to see this. That's why I say, unless you tell me your complex number or your factorizing skill is super solid, nobody will attempt to factorize it this way. Can? So, as much as possible, steer clear. So let's try. Can you do this question via quadratic formula? Try activating your quadratic formula by the side. Okay, this one is not in your lecture notes. I just want you to practice. Because since you guys asked a few questions, let's fast forward to this section. Okay, can you activate quadratic formula, which is your minus b plus minus b squared minus 4ac, that formula?
Oh, what's easier?
Can do, meh?
Thanks.
So you happen to get square root of minus 1. Oh. So it's 3i plus minus square root 1, right? Okay. Square root I or square root minus 1.
Oh, is it square root? Is it plus minus square root minus 1 is I or square root plus minus I?
It doesn't matter, plus minus will actually substitute each other. That's why I say it's a ridiculous argument. Can get this? Okay? So then you realize that, hey, this one is so much faster, right? Why must you go through this mess? Make sense? So half the time I tell you that quadratic formula to solve a power 2 equation is way faster. But what's the drawback? Again, you must understand the limitation. This one happens to be square root minus 1. What happens if it's not so nice? What happens if it's not so nice? Meaning, let's say if I change the question to this, let's say I change the question to this, z squared minus 3iz minus 2i equals 0. What's inside the square root probably have a real component plus an imaginary component. And then, if this thing, I don't allow you to use calculator, you will get some problem, right? Cannot solve. Can? Okay, so with this, just that leads me very nicely to introduce the next part to you. How do I find a square root of a complex number then? Okay, if I say I want it to be exact form. Okay, so I want you to find for me square roots of 3 plus 4i exactly without using calculator. Can you please highlight or asterisk this section? Finding square root of a complex number is a special skill that you better remember, and there is only one skill. What's that skill? Let z is x plus i1. Remember the method that I told you. Everything fail, activate this method. So what's going to happen is I'm going to let x plus iy be the square root of 3 plus 4i. Okay? So x plus iy squared will be 3 plus 4i. All I need you to do, extend the left. Okay, expand the left, regroup. Real with the real, imaginary part with the imaginary part. So you're left with x squared minus y squared plus 2i xy equals to 3 plus 4i. Always remember, when I let z be x plus iy, the criteria is x and y are real. Okay, x and y are real. So what to do next? By now you should know. If I say that this is equal to this, your basis of comparison will be real part compared with the real part, imaginary part compared with the imaginary part. Make sense?
What is it? Square root, not the square root.
Coming soon.
So that can be 2 roots.
Yep, coming. Can? After you do your basic comparison, real with the real, imaginary part with the imaginary part, you actually generate a simultaneous equation. Okay, 2 simultaneous equations for you to solve. Can you get your x and y to come out from there? Always remember, you're going to have quite a number of roots coming out. Always remember the basic fundamentals. X and y are real. So don't tell me x squared minus x squared equals to minus 1 for answer. No answer. Because we have already predetermined x and y to be real. Okay? So after you solve everything, what are the 2 answers that come out from there? You have x equals to plus minus 2. So when x is equal to 2, y equals to 1. When x equals to minus 2, y is equal to minus 1. So what are the square roots? Is 2 plus I minus 2 minus I. Correct now? These are your 2 square roots. So square root of 3 plus 4i, you have 2 answers, either this or this. So that explains the answer. Got 2 answers, man. Can?
Why?
Didn't I just prove to you mathematically? Agree?
Yeah.
Agree? Comfortable? Anything not clear? So far so good? Now I want you to press calculator. What happens? Try pressing calculator. This is your last bit for today. What happens when you press calculator?